لا ارسل لي انا عشان اشوف بس تركي لا بس الكراسي بدلنا تمام انا مو بسيب بس عشان اتابع معهم. يحتاج نوتس او كتاب رصاص موجوده هنا. وانا جاهز واحد منكم يعرف الرقم افضل. 19 11 الاسم محمد بصور فيها خلاص بس شوي
مشاهد اللي يبي قبل ما تبدا المحاضره شيء نشره.
ايه عشان البث قد شوي
عشان الصوت. طيب امسك الايباد، امسك الايباد.
بس
وين كان في ورقة؟ شوف الورقة.
بس كذا
ما اتوقع يبغى شيء حسب كذا.
ودي خلي السبورة واضحة
بس ما راح.
بس تشويش
شوف نزل شوية.
عندي ورقة
شوف ايه خلنا
واحد
كيف المكان بداية الصوت ليش كمان
اوكي لا اعتقد كذا اوكي
لو خليت الكيبورد يتكرر
افضل شيء ممكن اعمل
منفذ لو خليت الكيبورد يتكرر
نسيبتي
شوف حاضر كيبورد كده هذا ينشغل تنشغل تنشغل الميكروفون تحت
إذا ما حيصير لا مستحيل.
كم كتاب أو دفتر كتاب زايد دقيقة بس عندي كم
رجع ورا
ورا يا ابني وقف بدل
خلاص رجع.
يحاسب
لا ما احتاج. السلايد الأولى كل شيء لازم طيب. ممكن بس كذا ما تفعل. اسمع وخر شوي
شوف حط هذه اوكي تمام سوف شنطتي هاي للدوام
خلاص ويا الريد
السلام عليكم. تعال. كم مهندس ميكانيكي؟ أكثر ما شاء الله. كيميائي. ما حد ياخذ الدورة، هل تعرفوا الانترفيس بين التخصصين؟ هل في أحد عنده شوي تصور؟ إيه. ممتاز يعني بعد أنا جابرتك من قبل صح أخذت كورس الفايبريشن صح اي صحيح وهم بعد في الماتيريال ساينس شوي عشان كذي مثلا طلاب الكيميكال انجينير يدرسوا الماتيريال ساينس صح؟ بالنسبه للفلويد ميكانكس بالنسبه الى الكوروجن بعد مشتركات نوعا ما والهيت ترانسفير في يعني عده مواد ولان في انترفيس وهم بعد ان الكيميكال انجينير يقدر يشتغل بايبنج وان كنت انا ما ايد بس يشتغل بايبنج يعني الكيميكال يصير افضل في مجاله لكن في بعض الكيميكال انجينير يشتغل هم بعد بايبنج انجينير موجود فهو انه يصير عنده تصور ممتاز. طبعا لما يكون المهندس سواء كيميائي او ميكانيكي لما يكون يشتغل في البلانت كبلانت انجينير هناك بيكون كل شيء مع بعض يعني البروبلم ما تعرف الميكانيكال لوكال سولوشن في الاخر فقد اصلا الحل يكون متشعب يعني قد يكون اكثر من انجينير فيه وهذا مو بس بالنسبه للميكانيكال طبعا في بعد تداخل بين البايبنج وبين السيفل لحد ما لكن ما نتطرق اليه في هذه الدوره يمكن تكون في كورسات في برامج اخرى. عموما نرحب بالشباب كلهم ونشكر النادي على هذه الاستضافه اصدقاء. العام الماضي سوينا فعاليه كانت تقريبا مقدار 3 ساعات كانت هي عرض اكثر مما هي دوره لكن كانت يعني انتنسف يعني كانت مجهده بالنسبه الينا هم وبعد بالنسبه الى الحضور وهالسنه اعطونا المجال الى اقامه دوره اخرى. طبعا احنا مع الفريق فريق مهندسين من مختلف المجالات سواء في الهندسه الميكانيكيه او الهندسه الكيميائيه. طبعا جينا ممثلين عن مركز مستقبلي وهو برنامج يهتم كان يهتم بالتخصصات الأكاديمية، توسع شيئا فشيئا إلى أن أصبح مركز رائد يهتم بالتحفيز العلمي وتنمية الحس الابتكاري. في عدة برامج، من ضمنها برنامج الارتقاء الوظيفي. هذا وظيفته ان احنا نريد نرفع مستوى الطلاب من جهة الربط، لأن في الجامعة العالم بس نظري بس، خاصة طلاب البترول، خاصة يعني طلاب البترول، لأن ما فيها أبدا تكنولوجي، كله ساينس بحت. فنريد نوصل حلقة ربط بين الحياة العملية والحياة الأكاديمية، وهذه من ضمنها. أنا طبعاً في العمل تقريباً خبرتي الآن 10 سنوات، حدود 10 سنوات. هم بعد لما كنت في الدوام، يعني كنت في العمل تقريباً مدة 3 سنوات من هذه ال10 كنت مشرف على الأكاديميك بروجرام، على التريننج بروجرام. فكنت يعني مسؤول عن طلاب الجونيور انجينير، الفريش انجينير، الجونيور انجينير، والجرو اب انجينير، والسمر تريننج انجينير. سواء الخطة والمسار الوظيفي وإلين ما يطلع من هذا الحيز. فخلال 3 سنوات فواجهت يعني طلاب من مختلف الجامعات، سواء من طبعا الأكثرية من طلاب البترول، في من غير البترول. بشكل عام سمعة مهندسين طلاب البترول عالية، وصراحة استيعابهم ممتاز، ويقطعوا مشوار أشوف في العمل أسرع من غيرهم. يعني هذه شهادة، بغض النظر عن معدلاتهم صراحة، يعني بغض النظر عن المعدلات. والمعدل أشوفه ما يعكس، يعني أحيانا أشوف طالب قد يكون معدله 2 something، ويجد ويتفانى، قد ينتج أكثر من واحد معدله 3. انصافا يعني أتكلم عن شيء، عن واقع عشته يعني. نتكلم في البداية طبعا لعلي طول شوي. نتكلم عن البايبنج. طبعا انا ميكانيكال انجينير، بايبنج انجينير. الاخ المهندس يوسف العلي كيميكال انجينير، عبد الله هاشم كيميكال انجينير، علي التعتان وقف سيد ميكانيكال انجينير، محمد ابو خمسه. وفي واحد اخر له بايب لاين انجينير، بيتولى قسم البايب لاين، ماجد. المهندس علي بيتولى اللاي اوت، المهندس محمد بيتولى الماتيريال، الشباب بيتولوا الهدف. بس في البدايه طبعا من باب اللطافه، وش هو البايبنج يعني؟ طبعا احنا كان عندنا طالب سمر دائما اجيبها يعني. لما قبلوه طبعا هو ما حصل له لا ارامكو ولا سابو ولا حصل له اي مكان، خلاص توهق نشف. جابوه عندنا قسم البايبنج، قالوا له انت انقبلت في الشركه بايبنج انجينير في تريننج بروجرام. فيقول جلست انا في الليل افكر وش بشتغل، سباك. فكانت هذه الصوره يعني. طبعا نشوف العرض. طبعا بايبن له ميزه في السعوديه انه ما ادري انا اشوفه يمكن لعل الوحيد يعني انه يبدي الانجينير فيه من الصفر الى النهايه يعني بالنسبه للميكانيكال اتكلم يعني مثلا التصنيع تصنيع البايبن موجود هنا التصنيع عندك الايركشن والاكسكيوشن والكونستراكشن موجود هنا عندك الديزاين موجود هنا الانسبكشن والكواليتي موجوده هنا وايش بعد الاناليسيس موجود هنا الماتيريال سelection موجود هنا لاي اوت موجود هنا يعني ما ادري ما اقدر اعدهم بس يمكن مو اقل من 7 تخصصات هندسيه تحت البايبل كلها موجوده في السعوديه يعني من المانيفاكتشر لين ما تمشي في البلانت ما شاء الله مثلا لما تجي للبمبنج لا عندك مثلا مينتنس سelection بروكيورمنت خلاص سيلز توظف هنا البايبل لا يمتد اكثر فاكثر فما ادري اذا كان في تخصصات هندسيه تنافسه في المجال. الامر الاخر انه واسع جدا طبعا احنا بنركز في هذا الكورس على 3 مجالات في البايبل 3 مجالات او 4 بنركز على طبعا بنركز على السترس بنركز على الماتيريال وبنركز على اللاي اوت وعلى البايب لاين والرابط بين معهم من خلال الكيميكال انجينير يعني دور الكيميكال انجينير احنا في الاخير كل شغلنا اللي نسوي كبايبل كله في الاخير لعيون البروسيس كله في الاخير علشان الكيميكال يعني في الاخير تريد وش برودكت سواء كان اويل سواء كان سويت جاز وات ففي هذا الكورس بيتكلم عن المجالات هذه طبعا مجاله واسع سواء عندك في البتروكيميكال في الباور انرجي طبعا هي بالنسبه لتخصصات ثانيه سواء كانت في المصانع او غيرها بالنسبه الى مميزاته انا شويه باسرع لانه ما باقي وقت الجماعه طبعا البايبل تقريبا في معظم الشركات اللي انا مريت بها مريت انا يمكن 3 شركات كبايبل يعني اللي اتعامل معاهم او 4 انه يعتبر من اكبر الاقسام وقد عدد موظفينه يمثلوا 10% من الشركه يعني مثلا الشركه 1000 يمكن 100 في البايبل فمو شيء قليل يعني قسم هندسي يحتوي على مو شيء قليل يعني فطبعا هو يمثل يمثل من 25% ل 35% من الماتيريال بروسيس بلان شغله يعني يمثل من 30 الى 40% من الايركشن ليبر كونستراكشن ومن 40 ل 48% من ساعات العمل يعني يستهلك مجهود كبير وفي العاده ان شغل البايبل يمتد من اول المشروع الى اخر المشروع يعني ما هو يوقف يعني في ستيج معين يعني بعض الاقسام تدخل في ستيج وتمشي يعني مثلا تدخل يمكن بعد ال 30 بس تمشي شوي في المشروع تعال خلاص انتهي دورها لا البايبل بيمتد يسحب اياك الى الاخير على قولة واحد ستيف المفتاح زين فترك المجال الان للشباب
Major chemical engineer, and I'm working as a process engineer. I would want to thank the Mechanical Engineering Club for giving me this opportunity. And as you know, we see the course is mainly for pipeline, but the plan was to give an introduction to chemical engineering or process engineering, and we define what's the interface between the process engineering and mechanical engineering or solid pipe engineering, and what's the input required from process engineer to give the pipeline engineer proceed with this. So this is the main our ambiguity in this box. But as we have, mixed students, chemical engineers and mechanical engineers, let us proceed first with agenda. First, we'll talk about what's a chemical engineer and chemical engineer fields, and then we'll introduce you to process engineering. Because normally in the university we say chemical engineering, but in the market and industry called as process engineering. Process engineering is a part from the chemical engineers. Chemical engineering is a huge word, and we'll see that in the slides. Then we'll talk about process engineering design, what's the process and what's the field. Then we'll jump to the basis of process design more. Since we are process design engineer, okay, we'll talk about the design. We are working with the design companies as introduced by Hamad Sheikh, and we will see that. Then we'll proceed. What's the phases and المراحل المشروع نمر فيها المشروع, starting from process and the end of the projects. First of all, what's chemical engineering? I'm not a professor. Actually, you understand from your study as a chemical engineer or mechanical engineer. What do you think about chemical engineering? An idea? Sorry? ايه طبعا.
Converting the raw materials into items.
ممتاز. غيره.
Making sure of accurate gradient mass balances.
Okay, this is one of the tasks. Yes.
We basically upscale the process in the lab to a factor size one.
Yeah. This is if you can say working with the small scale and transfer to the large scale. It's good. Your ideas is correct because normally other majors know that chemical engineering is just handling the glassware, spatula, and doing this experiment. This is not right, or this is only a guide to go to the larger scales. And as per my understanding, as you say, chemical engineering involves the production, separation, and manufacturing of products through chemical and physical processes. This is not just a chemical. Also widely used in the physical separation, and this is widely used also in the chemical, starting from the oil and gas. This is purely physical separation. In like refiners also can find the jubel that some chemical plants or chemical processes. Also, chemical engineers typically work in manufacturing plants, research laboratories, as you say, or pilot plant. Pilot plant is normally located in the plants itself to test some processes. Also, they work around small and larger scales, as you said. And for the production equipment, that is housed both indoors or outdoors. Process engineering. نشوف شو الفرق بين الكيميكال والبروسيس. أحد عنده فكرة؟
You mentioned that process is about
Yes.
I would assume that it's directly related to the process other than plant control.
So you can say like this. Yes.
Process engineering will determine the steps to create a product.
We can say like this. But also process engineering, different types. Like I am process engineer, but working in design. It's not just dealing with the process itself. Sometimes we call it the production engineer. You can say like this. Or like he will monitor the process in the plant. Process engineer, but he's working in the research plants like this. But generally, we can say that process engineers are professionals who help to transfer raw materials into finished products. As we said in the chemical, this is a part of that. Also, process engineers serve allow companies to optimize the production process. Sometimes we have existing plants, they produce some raw materials, but maybe this process is costly, need to be enhanced. They want, for example, to get more profit. Also, process engineers can serve the company by, provide another solution, another non-process solutions, getting more profits. So sometimes you work from scratch, sometimes you work in the existing to optimize some of the processes. Yes, this is also we talk about the condition of the fluids. This is, part of the process to be, going smoothly to save the conditions, health condition can say to proceed with the production. Like I will show you in next slides how to control this. Let's say the environment of the fluids. Also, process engineering can include designing the equipment, as we can do. We design the equipment, pipeline also, as Mohammed just talk about this one. Controlling the process. Monitoring vital indices and analysis. Large volume data situated. Take action or لا في البلان المفروض تطلع الحين خلاص
مستحيل الدراسة
What does a process engineer do? Process engineer can do multiple tasks, have multiple jobs also. But in this class, I will show you what's the common activities for a process engineer. In this slide, I will show you what's the common process services of what can be served for companies, contractors, and vendors. Testing, monitoring, and maintaining equipment, including contacting regulators to make sure equipment complies with the recent standards. خلاص في مثلا equipment معينة في البلان شغالة. Process engineer duty to control this, to see whether this equipment is working as per the standards required or not. This is the work inside the plant. Researching, pricing, and assisting the purchase of the new equipment. Sometimes we need to design equipment for the company. So as a process engineer, I have some inputs to that equipment design. Then we'll go to the other discipline, mechanical problem, etc. Designing new equipment as required or redesigning the flow of the process in the factory or plant. Designing, modifying, and overseeing processes to guarantee maximum output with minimum defects in the production lines. هذا نقطة مثلا عندنا البروسيس بس مو معناته اني اشغل البروسيس وهي تكلفني مثلا تكلفة ولا اسوي اوفر ديزاين حق الاوكوبمنت وكذا لا في اوبتمايزنج overseeing the operation of the plant هذا في مسمى بعتبر كل process operation او process operation engineer هذا هو process engineer لكن شغال في البلان ومنها المنترنج اللي هو controlling the process. Normally you can find this in chemical plants. Overseeing the safety of the employees are the same. Writing, maintaining, and collecting require paperwork to show compliance with the safety protocols. Process engineers مش مهنته بس انه يشتغل ويسوي design. And في multiple documents, reports needs to be reported by process engineers. Some incidents, the process procedure itself, any problem in the plant, any, for example, for our design, there's list of documents you have to prepare at the beginning of the project. So also he needs to know how to report everything in the project or in the plant. Collecting and interpreting data on efficiency and budgets to report to senior management. شغلات تصير ساعات في البلانت، فيه مثلا historical data، فيه collecting data. Process engineers ما هو calculator بس يجمع المعلومات ويعطيها السنة. لا، he has to analyze and give his outputs to his senior management to discuss that. Analyzing every detail and step of the production process to cut costs, increase productivity, and optimize the production on how to do it. Okay. To go to the parting, we have to see what is the basic design. Basic design normally we use that in the design work. Okay, when clients come to the contractors, need to make his project, construct his plan. We have to do something called basic design. Basic design is the work for the plant construction. We need to construct new plant, we have to design it, and there are phases for this construction need to be done. Also to decide the basic design information plan according to the contract with the client. The client جايك عنده specification حق البرودكت، عنده budget معينة، عنده كذا، هذا تكون في البداية as per his requirements we will design his plan, and also we show him our ideas. Okay, some clients he thinks that he can do that, but in fact he cannot do that. For our duty to show him what's need to be done, what's the equipment needed, what's the process need to be optimized. The plan shows the required performance and function. In each project, these are the phases or المراحل اللي يمر فيها في المشروع. تبتدي أول شيء في الفيزيبيليتي ستدي. كونتراكتور أو الكلاينت عنده فكرة معينة، تبتدي في البداية يجي حق الكونتراكتور يسوي له فيزيبيليتي ستدي. هل هذا المشروع ممكن إنه يبدأ ولا لا؟ بعدين في شيء اسمه اللي هو الكونسبتشوال ديزاين. بعدها المرحلة المشهورة اللي هي فيد. Feed refers to front end engineering design. هذا يكون في البداية البيسك ديزاين وما بعد يصل details، لكن prepare documents to be shared then with the detailed engineering contract. تيجي بعدين مرحلة EPC. EPC means engineering, procurement and construction. Basic design هنا مكان في الانجينيرنج. يكون مصر the detail in engineering will be done in this phase. يكون في هو engineering calculation, but this is just for estimation works, for the cost estimation. But فعليا ما صار أي design حق المشروع. في detailed engineering يبتدي فعليا design equipment, design pipelines, design everything in the process.
طبعا في شركات متخصصة في الفيد، في شركات متخصصة في الاي بي سي، وفي شركات بعضها بس كونستراكشن. فمثلا من ضمنها شركات الفيد اللي هي جي اس بلس زي مثلا مود، وارلي، جيكابس. هذه تكون شركات تكريم، هذه تكون شركات فيد. في شركات لا تكون اي بي سي زي مثلا زي
طبعا هي كل مرحله فيها شاب لو بندخل فيها بنتشعب، بس احنا عندنا الحين في هذه المرحله اللي هي ديزاين اللي بيكون في الانجينيرنج او ديتيل انجينيرنج. Basic design. What's the most important items of the basic design? The first item, you're reflecting applicable codes and standards and contract content for process design. لكل مشروع في ستاندرد او كونتس لازم نمشي عليه. Sometimes الكلاينت نفسه يكون عنده الستاندردز والكونتس طبعا هذا عالمي. والستاندردز تصير سبيشال للكلاينت او للكونتراكت. لازم في البدايه يتحدد شنو الكونتس والستاندردز اللي يمشي عليها هذا المشروع. يعني مثلا ارامكو.
Maybe you need to explain to them what is a client. Because the word the client maybe they are wondering what is a client and what is a contractor.
الكلاينت اللي هو الشخص اللي يبني المشروع او اللي هو عنده المشروع. مثلا ارامكو كواليتي كلاينت سابق كلاينت. ذكر اليوز كلاينت. كونتراكتر اللي ذكرهم اخ محمد اللي هم من الشركات اللي تسوي ديزاين او كونستراكشن للمشروع مثل JGC مثل جيكابس مثل وورلد بيرسون. ثانك يو.
So usually for the plant operator, plant owner like Aramco and Sabic, they don't design the process themselves. They hire contractors like GGC, like other field contractors or detail design contractors to do the work for them. Later on, once the design is complete by these field designers, they take it to EPC stage, for which it will be handled by another contractor that will further detail the design and procure the material and take it into construction. And these stages can be applicable to greenfield, which are projects on empty land, nothing is there, or modification on existing fields. Like there are specific modifications, like Saudi Aramco comes to certain contractors or companies to do a modification on an existing process unit. We want to increase the flow. We want to produce more. There is an existing one, but we need to increase the production, for example. So we take it, we design, we say, okay, this certain equipment needs to be increased. Okay, this certain equipment is not suitable anymore to handle the new requirements. You have to demolish it, remove it, install a new bigger one, for example. So things like that, this is the difference between a client and a designer.
فتكلمنا عن كودز والستاندردز ان بعض الكلاينتس عندهم الكودز وعندهم الستاندردز so they request us as a contractor okay to follow their standards. Sometimes لا والله we can follow our standards. حتى الكونتراكتورز نفسه عنده their own standards. يعني Jacobs عندها standards, Fluor عندها standards, JGC عندها standards and practices. Depends from على الاجريمنت اللي بتكون بين الكلاينت وبين الكونتراكتور. The next item is the process engineering calculation. What contains mainly for heat balance and material balance calculation with process simulator, hydraulic calculation, which is include light sizing, pump specification, equipment design such as distillation columns, drums, separators, trays, heat exchangers, process safety valve design, flare design. Part of the process calculation mainly done by the process engineer. Okay, and based on his calculation, he provides his information to the data sheet that I will talk about later. This data sheet is the key for designing the equipment and save or show you the information of the equipment. In order to know the information of the equipment and also to purchase this equipment and also to share this data sheet with other disciplines like piping, mechanical, instruments, etc. Based on these calculations and the design information, our calculation outputs, we prepare the design information and drawings. drawings for the plans are PFD, which is process flow diagram, TNID is piping and installation diagram, and process data sheet that's it.
طبعا هذه نتكلم عنها هذه لا نحتاج قد تكون في اشياء ثانيه ما نحتاج لكن هذه احنا كبايبل نحتاج البي ان اي دي من عند بروسيس، نحتاج البي اف دي من عند بروسيس، نحتاج بعض الداتا شيتس من عند بروسيس.
This is the workflow for process engineering products. This is too small for that, but you can see in the top what I just talked about, heat material balance, design basis, feasibility study. I think this is specified by contract, EFD, PNID. So in these boxes you find what are the process matters or process inputs need for each phase or each step in this project. تكلمنا عن basic design work. Let us talk about the outline that I'm going to talk about. We'll talk briefly about codes and standards. How to prepare the heat and material balance. How to prepare the EFD and TFD. Equipment design, process data for installation and piping. Preparation PNID, water plan. Then we got summary for each for all of this. The codes. These codes are, international and used everywhere. And sometimes you need to follow some of these codes in your work. It's not just like I will calculate, for example, this length or this velocity or this properties. I will follow this design by my mind. No, this is different person agreement between the client and contractor, and based on some specification inside this codes. And this is the most popular codes that used in the industry. I think some of them you know by yourself, like ANSI, it's American National Standards Institute, API, American Petroleum Institute. This is a common word you will hear it once you work in the field, petroleum. ASME, which is American Society of Mechanical Engineers, ASTM, American Society of Testing and Materials, and ISO. All of these are words we commonly use, or we hear, or you will hear it in the future when you work as well. Okay. Standards, CIS, for example, this is Saudi Aramco Engineering Standards, and BEP, Shell Design and Engineering Practice. More, for example, for Aramco, you will see a list of the CIS, number and classified, and this will be used as guidance for your calculation for everything in the project. If the Aramco asks you to do all this. Second important thing, the documents, which is mainly prepared by process engineers, is a document called BEDD, which is Basic Engineering Design Basis. What's the content of this document? Is normally for general matters, it's unit of measurements, laws and regulations, rules and standards, as I specified. When you work in the project, everything needs to be made in a regular way. Not like, for example, I'm a process engineer, I will calculate my, or I will calculation will be in SI. Then piping will calculate using American. Other will use another units. No, we have to go as per unit will be single unit of measurements. Also the laws and regulations. When you go, for example, working in Jubail, there are some regulations. You don't have to, pass. Like how many, what's the emissions required? What's the specification of these emissions? What's the flow down? The seawater that will go to the sea. Everything needs to be as per these regulations that is located in this document. The same thing with equipment standards. The second is the utility conditions. Utility, we just talked about this, the properties. In the plant, there is a unit called the utility. This is contains steam, air, cooling water, and this is normal use in the equipment, like heat exchangers, like for example, also if you have some equipment need fuel, this is part of the utility. The instrument air used for opening and closing the valve. So this utility, it has conditions, like what's the flow, what's the temperature of the system, high pressure, low pressure, like for example fuel gas, what's the properties, everything is specified in this section of the PE.
So the environmental impact is done before this phase and the project life cycle.
As per regulations, no, environmental, you can say,
Because it's in effect, for sure. But which are which state? For sure it's before that.
you mean at the early stage? Or?
Yeah.
Sure, at the early stage you have to know this information. For example, if you talk about environmental, you have for example Royal Commission. They have their guidance to follow this, to be followed in each project. So at least you know this before you start. For example, if your process will emit this gas at this specification that this is not allowed by commissioning, so you have to optimize your process or otherwise you can do this.
So there is no specialist, environmental specialist study.
Sorry.
So there is no environmental studies.
No, there is the feasibility study at the physics. Yes.
Yes. Let me answer. Try to answer you. For example, let's take seawater. Let's suppose we are using seawater as cooling media in our plant. Seawater, we don't just go and take seawater. If, for example, we are designing a chemical plant in Jubail area, and we need seawater. If we want to take seawater, we will need to go to Royal Commission to get their permission to connect to their existing seawater pipelines. So once we connect seawater and we take it through our process equipment to cool whatever we need to cool, there is a seawater return line, right? Because it is a loop that we are cooling and sending back. Okay. Royal Commission, they come and say, okay, we don't want you to just dump the seawater that you just used to cool your process unit, just like that. We want to make sure that it is as per our regulations. We need you to test it before you send it back to us. And accordingly, as a process engineer, we need to have a place to test this seawater before we send it back to Royal Commission through their return pipelines. And for example, if there is a need, like for example, they will say, I don't want you to have a TDS value of this seawater exceeding 50,000, for example. So you go ahead and test it, and if the TDS is not matching, you don't send it back to RC Royal Commissioning because you will get a violation.
By the way, TDS is total dissolved salts.
Yeah, total dissolved solid in the seawater. Also the temperature. They don't allow you to send back very high temperature, so you have to have it, you sometimes need to cool it before you send it back. Otherwise, penalties may apply. So as a process engineer, you will need to design the required equipment to make sure that whatever we send back or we release to the environment from flare stacks or something is as per the regulation of that area. And in our region here, it is the Royal Commission. They have all of the environmental regulations. On top of that, they don't only rely on process engineer to make sure that the process is up to the standards and requirement of the regulations. Some specialists, they call it, for example, one of the studies usually done on any process plan, something called EIA, Environmental Impact Assessment. They will ask you about each and every single release you do, either through pipelines, through the air, through anywhere, and they will do a study and will make sure that it is as per the local regulations.
Just a quick question. Why is, in the utility conditions, it's very important to mention in this report. What do you think? Regardless the environmental issue. Any idea? What's the important things that, especially utility conditions, need to be mentioned in this report? Especially
because all the utilities are connected by pipelines to the food that they feed.
yes, and what? Why?
Maybe because they're losing water, air, or something that they use to
Yes.
Turbine cost.
They are under continuous use as long as the process is going, so they will be used. So we need to maintain them at a specific known conditions.
Exactly, yes. Because here, for example, for cooling water, we'll specify what's the cooling water burn and what's the cooling water return. So by this, you will design your equipment and you meet the specification for the downstream equipment of the cooling water. For example, you cannot send, for example, cooling water, this is sent by in the 44 degrees C, you cannot send it to the cooling tower again at, for example, 50 degrees. This will affect the operation of that equipment. And also will affect our design. If we know the utility condition, we start designing our equipment at the beginning based on this condition, like heat exchangers, like any equipment that using steam. It depends on the utility condition, the supply condition and the return condition or the emission condition. This is the important. Also site conditions. I will go for just to its parts. Site conditions, like for example, what's the topography, metallurgical data, temperature, humidity, pressure. This is also will help civil and PMT. Soil characteristics. This is all, also for civil to know for the basement, for anything that underground. Environmental info for HSE. Basis of the equipment, falling factor for heat exchangers, this is all that process as well as the mechanical ones. The second important document is called process design basis. Process design basis is, you can say, the heart of the product. Because see what it contains. It contains the requirements of the plant design. The background of the project, what's the idea for the project, what's the main things that need to be, produced in this project. Plant capacity, how much is in, how much is out. Feed, product, semi-product specifications, design markers, 10%, 20%, 30%. You have to know this because this will affect your design equipment. Sparing philosophy, you have one pump. How many spare? 1, 2. How many operation? 2 operating, 1 spare, and that's it. Emergency shutdown philosophy. For each plant, there is emergency shutdown to take place when an emergency is happening. Also, there is something is written in this document. Future expansion plan, as Abdullah said. Some client, for example, after 10 years, they want to increase their production rate. So, for example, is there any area spare for that one? Is there the equipment is designed for the future or not? Everything is mentioned in this report. And we'll see how this report will help you in the design of the upstream programs.
I have a question. If a client asks to get a design for a factory or any institution that they need, do they have to specify that they may expand in the next 10 years?
Yes.
If they don't specify, so they have to build another institution or
Yeah, this is as per their plan. Sometimes you can revamp the equipment.
Yes, I can add if you allow me. So sometimes when you get a request to design a certain portion of a plant or a plant, you take into consideration future expansions. But they are up to a certain margin because you don't go and design a plant to handle, for example, 100 ton of certain chemical to be produced, and you put 100% design margin. So that in case you want to go to 200, this is not logical, right? So maybe 10% to 20% can be taken as a future expansion, and all design engineers, piping, process, they take into consideration their design, some design margins, like 10%, 20%. If they are more than this 10 or 20%, it has to be specified by the plant owner. Because I am clear in my vision that I will take this plant to be operated at 160% after 10 years. And I want you from now to design it to handle that capacity. Okay, some challenges may arise, by the way, because it is not always visible to design an equipment to handle specific production rate or special flow rate, and you will start by operating it at 60%, for example, from its capacity. It's not always feasible. Take pump, for example. If you have a pump curve, right, flow or pressure head versus the flow, you have a pump curve. So, for example, if you start by 60% of the flow, you are at the very low, on the very left of the operating curve, and you are consuming so much power on that pump. Until you reach 6 years or 7 years to operate at your normal or design capacity, you may have consumed a lot of power unnecessarily. So there is a compromise between future expansion and design considerations.
Okay. Preparation of heat and material balance. Heat and material balance are prepared by simulating process scheme with balancing heat and materials. And as a chemical engineer, I think you already know about this and what's the importance of heat and material balance. These are the one of the more important basis of process design. Then either heat or material balance is not done properly. This will affect your design. This will affect, will create many errors in the plant, in the operation and the design. So better that we concentrate in this system and provide, valuable products. Simulation is done with process simulators. And كنتوا في الجامعة تدرونها as in and out and calculation, but in the companies they use normally approved softwares like HYSYS, and studying operating conditions, temperature, pressure, and flow rates for meeting specification and optimizing the process. Heat and material balance, as I told, is very critical for the design should be studied carefully. A corporate physical property estimation model for handling fluid is important for process simulation. Like if you know what's the properties, what's the behavior of the fluid, okay, you can study the products or the process very well. And also don't forget the thermodynamics properties. This is will also help us the heat balance, heat vaporization. Sometimes you need this property for the steam. So many properties will help you during doing this simulation. Transport properties used for sizing equipment, viscosity and conductivity, especially for hydraulics. This is a snapshot of the Proto software that you will see the feed streams and you can choose the equipment. Like here we have mixer, then we have drum or vessel, then we have maybe this distillation column. Based on that, you will see what's the inlet, what's the outlet, for example, what's the overhead flow rate, what's the heat exchanger duty, like this, and you will tabulate all of this data in the table streams. Preparation of the PFD and PFD. What's Muhammad also introduced. This drawings will be an input for the other disciplines like pipeline engineering. Block flow diagram shows unit configuration of the plant by block and line. This is just a concept or schematic diagram that will show you, simply what's the process, what's the actual process. This will not include in the design. This is just a pre-step for the next project, or to understand what's the process. The process flow diagram, which is called PFD, shows the equipment configuration by sketch and major process control, hidden material balance, and operating condition. It's starting going from process design. Let me show you one example. This is an example of one of the SABIC projects block flow diagram. This is a utility, wastewater plant. If you see, this is the plants or the units inside the plants. They will send the wastewater to these units. Okay. This is BPCPS, olefin 3, olefin 2. This is a unit inside the plants. This all also will show you that wastewater will be sent to this equipment or these packages, like centralized in a certain dock system. I know maybe you didn't understand this unit, but just I show you the idea how to describe the process itself in terms of plots and bars. Just to give a step to understand the process, and it will be pre-step to providing or preparing the other products. We'll go back to our presentation. Now we're talking about the PFD, process flow diagram. PFD is different, it have more details than block flow diagrams. It will show you the production scheme for feed to product by sketch. Equipment configuration, how many equipments inside the unit itself. And also it will be named. Every equipment will have tag numbers, okay? This tag numbers will show up on the top of the drawing, and the description of the equipment will be written. Heat and material balance, operating condition, temperature, pressure, operating condition of major equipments, streamed data of major lines, flow rate composition, heated duty of some exchanger and furnace, major process control, flow, pressure, temperature. I will show you the drawings just for more understanding. This is an example of PFD. If you see, for example, this is a drum, this is a package. Normally the package, it's a collection of the equipment that this is will be provided by Filter. Okay? So he is responsible about this package. So normally we show it as a dotted line, okay? And we'll show the description of the package. This is the dotted line between the package. This is a tank. This is a deaerator, and also this is a filter. See the description of each equipment.
by tag. And normally, these strings are named by serial numbers. Okay, these serial numbers related to the stream information. Actually, this PFD is done in the early stages, but normally it is in tables. So these numbers, each stream will show you the name, properties, condition, temperature, pressure, what's the condition, etc. Now we'll move into the equipment design. By starting the equipment design, or after starting the calculation, we have to, prepare the data sheet for this equipment. We have several types of equipment, like static equipment, column, vessel, tanks. When we size this equipment, we will prepare the data sheet and provide our process information in this data sheet. Then this data sheet will pass to the mechanical to provide their information. Also sometimes pass to the other discipline, okay, then to the purchase. Rotary equipments like pump, for example, we make our hydraulics, find some process information, then this will tabulate it to the data sheet, okay, then it will go to mechanical. And also some combustion equipment like fire heater, flare stack, etc., instrument, every equipment we make some calculation, we have to put the information, process information in the data sheet. We call it process data sheet. Also, there's data sheet for piping called LDT, line index design, or LDT line designation table. This is the information that will end up as a process engineer, like temperature, pressure, design temperature, design pressure, will be filled up to the piping and it will be an input to piping to proceed with their design. عن البايبنج ما يقدر يشتغل من غير هذا، صعب يعني، خاصة يعني اسم الانتيرير أو صعب يعني يعتبر من most important وفيها كل لاين تاج نمبر الاسبكت اللي بيتكلموا عنها تمام مع البروبرتيز اللي هو التنسيق والتمبرتشر. طبعا صحيح ان البروسيسور اللي يسووها لكن البايبنج يسوي لها كروس تشيك، فإذا شاف قيم يعني مو معقولة يعني دائما الليلة وايد عالية أو كذي يرفعها للبروسيس مرة ثانية يتأكد يسوي فيها جستيفيكيشن فعلا تغيروا هذه القيم أو إن هي مثلا باي ميستيك.
Yes, as Mohammed said, I just talked briefly about this data sheet, LDT, what's for process and that one, what's, in coming days he will talk deeply on this one.
Yeah, I will speak also in some details about MDT.
Also, we have instrument data sheets. This is mainly, it will go to the instruments that they deal with the, any instrument equipments like valves, analyzers, safety valves. Some designs is come from process like safety valves. We make some calculation, okay? We will end up with some specification with this specification in the data sheet. So this data sheet will go to instrument also to proceed with the work.
طبعا الشغل معاهم في السيفتي فالف لما يكون مثلا في فايبريشن هني نرجع اليهم لان هذا الفالف من البروسيس البروبرتيز من البروسيس صار في فايبريشن بيأثر على الفايبر يصير مكتل ويكون كونتينيو مشكلة واش يصير كورس مستقبل.
Okay, line index LDT that is talking about. It's mainly we as a process engineer will provide a piping site, operating condition, design condition, density, insulation for one by one, for every pipe. We'll see all of the piping. Once Abdullah will start talking about the ideas, we'll see every pipe there is a tag number. Okay, this is listed in the LDT. For each line, you will see this information and this. Yes.
Does this include the, for example, the working pressure and the pressure and pressure test values?
Yes, and this is already calculated by Python. We provide the operating pressure. The output test pressure will be calculated by Python. There is piping, what's called this?
Specialty items.
Specialty items. Yes, like a strainer, like mixer. Also, it needs sometimes some input from process. Like for example, strainers, what's the particles size, for example, this is normally provided by process. What's the pressure drop inside this specialty items, we provide it also by process in the data sheet.
طبعا بالنسبه للداتا شيت حق سبيشاليتي ايتم فيكون بعض الشركات هذه الايتم تسويها البروسيس وشركه ثانيه يسويها البايبل.
Yeah, it depends. For example, I work in one of the companies that heat exchanger should be designed and rated by process engineers. In the another company I work in, the heat exchanger is designed by mechanical engineers. So this is different from company to company.
يعني تصير عندك باك جراوند مهم يعني واحد يقول لي هاي شغل لكل السنه ما لي شغل لا في ميكانيكال باك جراوند behind مثلا الفالز مثلا هذه في البروسيس انجينير له رول الميكانيكال انجينير له رول بعض الشركات تتفاوت واحد يكون تحت بروسيس واحد يكون تحت وهكذا
To be fighting each other. Okay. This is example of the data sheets. And as you can see, this is a process data sheet for the vessels. Normally we see schematic diagram for the vessels. What's the width, for example, what's the length, the location of the instruments, what's the design condition, operating conditions, like this. These are the inputs that come from process engineers. You will see another item, I know this is not clear, but for example, you see another items or not. This is maybe added, for example, by mechanical engineers. So as I told you, the process data sheet, it will pass to the other discipline. It depends on the function and then what's needed from which discipline. For example, yes. Yeah.
طبعا احيانا القسم يعلق تقول احنا اوكي هذه كلها اوكي هذه الانبوتس بس عندنا مشكله في هذه ممكن نغيرها او ممكن تصير مثلا طلب يعني.
Sometimes, I'll give an example of that. Sometimes we design an air cooler, for example, to be placed on the top of pipe rack. The pipe rack is a platform where the piping engineers they route their piping from. And for example, as part of the process, we want to cool these pipings. We want to bring them from temperature to a lower temperature. And in our specification, or when we design the heat exchanger or the air cooler, we say that the pipe length of the air cooler is, for example, 30 inch. And it is not a greenfield or it is not a project from scratch. It is an existing platform. Sometimes I get a comment from piping to say, Mr. Process, you are saying you need the pipe length of the tubes of the air cooler to be 30 inch, while I cannot accommodate that. Can you reduce it to 26 inch so that I can accommodate? I tell him, okay, I'll go back and redo my calculation and see whether I will get the required outlet temperature based on your new pipe length. So it is a two-way communication between process and pipe to optimize.
Material science, is it R&D? Your technical process all the time. And you want
I will speak about that in my first slide. But to brief you, basic material selection is done by process engineering because we understand the fluid passing through the pipes and what is the equipment are accommodating. We we know that this fluid is corrosive, for example. We know that this fluid containing chloride. So certain materials are compatible with certain fluids and others are not. So basic selection, but nowadays there are certain plant owners, they are not in favor of having the selection is done by process engineer. They want it to be done by a specialist or a meteorologist or a corrosion engineer. There are different naming for this specialist who is doing the final material selection. But basic material selection is by
So normally how many engineer specialists? One for example.
one is enough. One is enough.
Process engineer, piping engineer.
Depending on the size of the project, you can start by having a project containing one process engineer, and for example, the project I'm working on now is having 30 process engineers because we are designing a new chemical plant from scratch. So 30 process engineers and more than 100 piping engineers are working on this project only. So you might have it different. Sometimes if you are having only modification of it on an existing system, you are installing maybe one pump and one tank and these kind of things, you only need one process engineer and maybe 3 or 4 engineers.
Now public engineer specialist, now civil, now civil engineer specialist.
There are all of the disciplines that you can think of. There is process engineers, there is piping engineers, there are mechanical specialized on static equipment, not rotary, like columns, drums. There are engineers who are specialized in mechanical pumping or rotating equipment engineer, civil, structural, architectural, all engineering disciplines are involved once needed. So for example, architectural engineers are needed when you design a building. But if you are only modifying certain equipment or certain system of your plan that is not related to architectural, they will not be involved. So the involved engineers will be based on the requirement of the modification or whatever you are trying to design.
Let me give you an example. For example, for this equipment, okay, as a process engineer, I will provide what's the physical properties, what's the I need the type of materials, what's the condition. I will provide the sizes of the equipment. Then this is will pass to mechanical also. Then to go to civil, there's I need of what's called this foundation or anything. It will go to the civil engineer. Also, we have instruments. If you see the level control, level instruments, pressure elements, this will go to control system. So everyone, as he said, is involved. See, the discussion is, very beautiful to discuss deep in this one, but we have to pass. Yes.
Assalamu alaikum everyone. My name is Abdullah Hashim. I'm a process engineer. My background is chemical engineering. I understand that most of you are mechanical engineers, but what I'm going to talk about is engineering. So it is understood by mechanical or chemical. There are important things or important input, we call them, to be given to the piping engineer. And since the course is piping and pipeline, I will not take so much talking about process, but I will be concentrating on the most important input or deliverable, what we call deliverable, which is the piping and instrument diagram, for which the piping engineer will base all of his design on this deliverable. So what does process communicate with piping through the PIDs or piping and instrumentation diagram? Material of the piping, the size of the piping, the valve types and their sizes, any required insulation, cold or hot, flange rating of the pipes, the specialty items. There are other important messages or information we communicate through the BNIDs, but these are not related to piping, so I will not be concentrating on those. So the first thing is material selection. So there are certain factors or important factors that we should take into consideration when we do material selection. The first thing is the fluid composition. For example, if your fluid is corrosive, you know that from the composition of the fluid. If your fluid is having chloride, for example. I'll give you one story, that funny story. Basically, when you design or select a material, some of the times you having a hydrocarbon, for example, right? Like, for example, you take this as an example, you are having a hydrocarbon through a pipe, and it is a corrosive. It was a gas that is a corrosive gas. So usually, you will start with carbon steel. Carbon steel is the basic material to accommodate hydrocarbons. But once you have this corrosive wall attached to the hydrocarbon, most of the times people or process engineers or metallurgists, they go to stainless steel, because stainless steel is more compatible for corrosive surfaces and it does not corrode. This is the main idea, right? So what happened in that case? The metallurgist chose stainless steel as the material of construction of that piping that is containing the corrosive gas, and it is called hot gas. And he didn't pay attention to the fluid composition, that it contains some chloride. And if you go back and check, if you have a chloride with stainless steel, this is not compatible, and it will lead to certain types of corrosion. It's called induced cracking corrosion. So even higher grade, if you just think of fancy material to accommodate and just get rid of the headache, it's not always the case. Sometimes you need to pay certain attention to the fluid composition to end up with the right material selection. Another thing is the fluid conditions, operating conditions, like if you have high temperature, specific materials have to be selected. If you have very low temperatures, also specific certain material, because if you take carbon steel, for example, normal carbon steel does not withstand less than minus 18, I think, 18 degrees C. So if you have a system that is handling a flow of liquid in a refrigeration unit, for example, and it is below minus 18, so you will end up with a not a suitable material. So you have to take into consideration the operating conditions of the fluid passing through the piping before you select the material. Of course, as engineers, you always pay attention to the cost, because at the end of the day, what you are designing is cost related. And you want, at the end of the day, to have your CAPEX and OPEX aligned so that you are not ending up broken or break even. You want to make profit at the end of the day.
تمبرتشر بعد مو بس احيانا طبعا احيانا بصير في ايرور، يعني ماتيريال اصلا هذا الماتيريال كانت withstand up to this temperature.
Exactly, like the refrigeration unit. And if I choose carbon steel, normal carbon steel, not because there is another type of carbon steel called low temperature carbon steel, and that one withstand up to minus 45, for example, degrees C. So certain attention has to be paid to the temperature, the operating conditions of the fluid before we select the material of the pipe. There are other factors related to mechanical. We leave them to the mechanical team. We are not bothered with them, like stresses and shears and these kind of things that I don't like much. So we leave them to the mechanical team to decide and to see whether the basic material I've selected as a process engineer is compatible according to the design. So just briefly, these are the type of materials that we usually see and choose for piping system or equipment as well. We have metallic, non-metallic, and line cladded pipes. In the petrochemical and oil and gas industry, you will almost always you will fall in this category for hydrocarbon services. Carbon steel is on the top of the ferrous. Here, ferrous and non-ferrous is related to the iron existence, because you know the element iron is Fe, ferrous, in the I think Latin language or something. So this is related to the ferrous and non-ferrous. These are mainly based on iron, Fe, and carbon steel also on the top of the list. if you have corrosive surfaces, sometimes you go to non-metallic. For example, if you have a fire-water network, you know water is corrosive surface. So you may end up with choosing what is called HDPE or PVC for these services. So whether it is corrosive, non-corrosive, low temperature, high temperature, you have to pay attention to these things before you end up with your material selection.
Who decide when, at the plant, especially, who decide what type of intermediate material is it? So, who decide when we go to gasket or BX or O-rings?
This is a piping related question.
Again, repeat the question.
At the flange, so some pipes has gaskets, some pipes have BX, some pipes have O-ring metal. Who decide what we want there?
We cannot answer this question now. Keep it for the material selection. Very fast.
This is I couldn't answer this because this is pure piping
This is
related.
private. We will come to it. Related with the flange selection and gasket. At what basis you selected this and at what basis selected this.
So you will go through this, right?
Yes, you will go through this, but this is very far now. We cannot go through this.
البايب كامل هل ممكن يكون أكثر ماتيريال يعني مواد طبيعية في زيت البيزنس يستخدمون الماتيريال هذا ما يستعملون البايب كامل عشان يكون عالي.
Yes, you are right. In the specific plant we are designing now, we have a small portion that is stainless steel and the rest is carbon steel. So you may end up with a specific portion of your plant or system that is having different material because only on these specific portions you will have different operating conditions that you cannot go beyond and you have to select the right material for so that you don't end up with non-compatible material.
وطبعا هذه تهمنا احنا كسترس وين البريكنج بوينت حق الماتيريال عشان لان الاناليسيس يختلف بين هنا وهنا هذه لازم be given from the process. Where is the breaking point?
One of the most important calculations that process engineer is doing is what's called hydraulic calculation or line pipe sizing. You will see the word line a lot, but when we say line, it is pipe. We call it a line. This is, I think, the language that we use, right? Because you might get confused when you see line. What is line? Whenever I say line or it is mentioned the line, it is the pipe. We call it the line going from here to here. This is the pipe, the piping system going from here to here. So one of the most important inputs or calculations that process engineer is doing and communicating through the BNIDs is the hydraulic calculation or the pipe size. So the process engineer is responsible to determine the pipe size going from here to here. I wanted 6 inch, 8 inch, whatever, and we put it in our drawing, which is the piping and installation diagram. Then the piping engineer will take it for their further detailing and development of their documents. So the main purpose of the line sizing calculation is to what? To determine the pipe size and the pressure drop. I think it is going to be well understood because most of the chemical and mechanical engineers are taking fluid mechanics. So it's going to be an easy language. So these are the aspects to consider during the line or pipe sizing. First thing, we have to keep in mind the continuity and Bernoulli equations, the fluid properties, pressure drop, net positive suction head. I will specifically talk briefly about NBSH because what I noticed that most of the chemical engineers, they don't graduate with this concept. Or I think is it still CG204?
Yes.
CG204, fluid mechanics. In that course, this is the only course where chemical engineers, they study fluid mechanics. And in that course, I don't think we are graduating with the concept of NBSH, so I'll shed lights on it. pipe erosion. This is one of the aspects to think about when you size a pipe. And there are special pipings related to relief and depressurization. I'll speak briefly about it. And I'll give some examples of some of the most common process engineering software used for hydraulics or line sizing calculations. So why fluid properties are important in line sizing or piping sizing? Because of this. When you have a liquid, it's different than when you have a gas. When you size a pipe to handle a gas, is different than sizing a pipe to handle liquid. And why? Simply because the gas characteristics behavior is different than the liquid. And the reason behind that is when the gas is a very strong function of density. So for example, if you start at the beginning of the piping system for a gas system with a pressure, and you end up with at the end of the piping system a different pressure, different density profile across the pipe. But take liquid, for example, and compare it, you will see the density is almost constant. So the liquids are not a very strong function of density, and hence, as a process engineer, we always take into consideration when we size a pipe to handle a gas and a pipe handling a liquid, we take this concept into consideration, and we pay more attention, for example, when we size a pipe that is handling gas, because we know the characteristics are changing across the pipe, and we size it accordingly. So this is just a reminder, I'm sure all of you are aware of this. This is the continuity equation. From continuity equation, I want to derive at a very basic conclusion, which is when the pipe diameter decreases, what happens to the speed or the velocity of the fluid? Increases, right? Also, the sum of all pressure, kinetic energy per unit volume and the potential energy per unit volume has the same value. This is Bernoulli principle. It is a well-known principle. And you know, in the chemical plant, when you do the sizing of the piping system, you will not have a straight line going from A to B. You will see it going up, crossing a certain curve, going through platforms, going down. And when we size the piping system, we have to look at the bigger picture, and we take into consideration the elevation changes, the increases in the piping diameter, decreases in the piping diameter, so that as a full system, it is well sized and accommodating the flow rate and the velocities requirements. Yes. Yes.
Why are you not considering the losses?
We are. We are considering the losses also in the pipeline. Like frictional losses, I will come to that. They are considered for sure. And these are the most important thing, for example. For example, if you design a pump that is pumping a fluid from point A to point B, you are concerned about the arrival pressure, right? And this is why you are sizing the pump, for example, to arrive at that destination with that required pressure. So you are concerned how much pressure drop or frictional losses you will lose through this routing of the pipe, and you arrive to that. So that you have to consider the right pump pressure, source of pressure to derive or arrive at the destination pressure. So pressure drop concept, and this is actually the next slide. Pressure drop concept. And the pressure drop concept is mainly Darcy equation. I'm sure most of you has heard about Darcy equation, and the Darcy equation is related to the pressure drop. So this is just a very basic conclusion. If the pipe diameter decreases, and it is in the denominator, right? So what happens to the pressure drop? Increase. So pressure drop increase. Also the fluid velocity will increase because if you compare here the pipe diameter, as we included in the continuity equation, when the pipe diameter decreases, the velocity increases, and the aging of the piping. because as you mentioned, the frictional losses and the continuous frictional losses through the piping will affect the age or the life of the piping system. Another aspect that a process engineer should take into consideration when they size a piping system is the pipe origin. When do you think we will have piping origin? At what condition? High velocities, right? When you have a pipe, yes?
Low pH.
Yeah, this is another thing. That one we classified on corrosion-related things rather than erosion. But mainly the erosion is due to high velocities and turns, for example, in the piping system, like in the picture here. Here we have high velocities, more than the pipe can handle, which led to eroding the pipe with time. You wanted to say something? So line or pipe, high velocities lead to high pipe erosion, which is reducing its lifespan. As process engineers, there are critical piping systems that we don't only rely on velocities limitations to decide whether this pipe will erode or not, but we refer to an international standard called API 14E to use certain equations based on flow rate and conditions, operating conditions, and we know that are we operating this piping system to handle the erosion, are we within the limit of the erosional velocities or not? For example, if our velocity, our line velocity is more, and the erosional velocity we calculate from this standard is less, then we are above that and we are subject to erosion, for example. So we have to make sure in some critical piping system, especially inside heat exchangers where replacement of piping can be difficult. So you might ask, how can I know that my pressure drop is within the limit or not? You might ask, what is my velocity limits? How can I judge as an engineer or as a process engineer? How can I judge that my velocities are within the limit or not? Usually there are standard requirements, international standard requirements, like the picture here, if you can see. There is here typical pressure drop per 100 feet of piping across a piping length. And for example, let's say you are designing a pipe or sizing a pipe that is at the discharge of a pump. You know from the guidelines that you don't want to exceed a 4 pxig per 100. And you don't want your velocity to exceed 15 feet per second. So there are guidelines to help engineers decide whether they are within the limit or outside the limit. And beside these international standards, there are owner or plant operator requirements. Like if you go to and design a piping system for Saudi Aramco, they have standards, written standards, documents engineers refer to decide whether you are within the limits or not. Like for example, you have a clean product, let's say gasoline. Gasoline is a refined and clean product, and you want to see your piping system is suitable for this or not. In Aramco standards, you can refer to that and see whether you are within the required velocity limitations or not. So they are making your life a little bit easier by mandating certain values rather than just coming up with the things based on international standards.
But isn't that limiting your area?
Sometimes yes. Sometimes you have to compromise. Sometimes you have to ask them to waive the requirement because you don't have, for example, plot limit or plot space limit. And to avoid high pressure drop, you are increasing your pipe diameter, right? And you cannot accommodate such piping system. So you go back and tell them, how can I go beyond this? I cannot increase my pipe diameter because the current piping or plot limit is not allowing me, while your standard is not mandating this pressure drop requirement.
I have one additional on this matter.
there is a criteria that, for example, above the pipe rack, which is I guess cloth pipe lighting, you cannot put the pipe below 2 inch, right? So sometimes your calculation, 1 inch is enough. For example, this is the velocity or pressure, but you will go with 2 inch because of the light.
So, as I said, there are some general velocities limitations, lower limit and upper limit. And we can understand lower limits are, why are lower limits mandated? Because of corrosion. If you have settling of fluid inside a piping, and this fluid is corrosive, for example, it is more prone to corrosion, right? If you have settlement. On the other hand, if you have, the upper limit is meant for original purposes. Like high velocities will make erosion to happen faster to the pipeline. Also, another message I want to deliver: when you design the limitations or limitations of a fluid inside the piping varies based on the phase of the fluid. If you have a liquid, you can see that the minimum is 1 liter per second and maximum is 4.6. However, for gases, the allowability is more because the gases' speeds or velocities are very high. It is okay to have, and these limits, if you can see, they can go as high as 60 meters per second.
Does this specifications changes when, for example, we are dealing with upstream, where we may have sand or?
Of course. Yes. These are general, as I said. Very general, that when you want to judge just from your top of your head, without very detailed calculation, if you are within your velocity limitation or not, these are some guidelines that you need to keep in mind so that you can, as a process engineer, doing line sizing, you can judge, okay, I think we are fine. 6 inch is suitable for your surface. From the top of my head, I can say 6 inches is suitable. But if I further investigate more and find that my surface is having solids and my surface is more corrosive, my surface, no, you might have different things. If my surface is corrosive, maybe my lower limit is not going to be 1 meter per second. It's going to be 3, for example, because I cannot afford to have the liquid settle so much so that I can lead to corrosion.
Some applications we typically have like relatively big margin in terms of flow rate. Sometimes you want to have high protection, sometimes you have low.
Correct.
And in terms of velocity, are very limited. How would you optimize this?
This is a very important point. Very important point. What he's asking, sometimes you have startup conditions, turn down conditions. As a process, there are some requirements for turn down, and your flow rate can go to half, for example. And in your normal operation, your flow rate is 100%. During the line sizing, you have to take consideration for those operational scenarios. Sometimes you are lucky to have them within the standard requirements. Sometimes only your, if you go with the huge ranges, like if your lower limit is 50% of your normal and your upper limit is 60 or 70%, it is unlikely to fall in this category, for example. But most of the cases you optimize. So you say, okay, I will have my velocity to be within the normal range during normal operation. However, I might go below the allowability during turn down, which is for a specific period of the time. It's not a steady state that we are designing our plant accordingly. If we are lucky to have them within, then okay. Otherwise, we will have to optimize. And we will have to also document this, that what we found out is that this piping is suitable to handle normal and maximum, for example. Not the minimum, because it's going to be outside the range. But with the proper justification that this is going to happen only, for example, 10% of the year, so you can go beyond that.
Are we always looking for laminar flow or turbulent flow? Or it depends on the project, the pipe versus the
For the piping system, it is not always the case that we are bothered with laminar or turbulent flow unless we are doing multi-phase. So sometimes I did not speak about this because it is more in the to size a pipe handling two-phase, liquid and gas. For that, you might take that concept into consideration. Also, flow rate, laminar or turbulent or transit inside the heat exchanger or a vessel that you want to do separation. In those specific scenarios, you will take into consideration Reynolds number and these kind of things to understand the flow behavior inside an equipment or inside the piping system. So
طبعا كميكانيكال في بعض الابلكيشن قد نحتاجهم في الفايبريشن.
بس اللامينار والتربولنت هذا part of the process. I agree with ساعات من البروسيس يحتاج مكان هذا. فاللي هو البايبنج they will take care of vibration and support.
As I said, the source of this information or these limits are Aramco standards and common industrial practices. When you go to SABIC standards, if you design a system for SABIC are more relaxed, I can say. Their limits are much higher than this. Because Aramco is very, very conservative. Very conservative. You will notice that if you work in Aramco or you work for a project meant for Aramco, they are very conservative. Their engineering standards actually, they are based on international standards with very specific margin. Like if the international standard allow for 3 meters, they will go, okay, 1 meter. They will just cut it by 20-30%. Mostly, I'm not saying all the time. Yes. NBSH concept. You will see or you will have to calculate NBSH whenever you are designing a pipe that is at the section side of a pump. This concept is only for liquid and it is for the pipe at the section of the pump. That's it. This is the only part where you will be taking care of the NBSH. So what is NBSH? Maybe it's better to draw. So suppose you are designing a pump and this pump is taking its flow from this is the destination. And this is a tank. And this is a pump. Okay. You want to size this portion. You want to decide what is the pipe size here. So the most important thing that you need to look at, beside the velocity and pressure drop, is the NBSH. Because what is critical in pumps, you don't want pumps to cavitate, right? Because if you have less pressure than required by the manufacturer, you will end up cavitating your pump. So how do I ensure that I have the sufficient pressure at the section here, exactly here? This is the section of the pump. So I want to make sure that this NPSHA, so another term is called NPSHA, and the A stands for available. So available versus required, because the required here, the NPSH required is mandated by the pump manufacturer. So the pump manufacturer will say, okay, to pump your fluid from this point to this point with your fluid conditions, the flow rate, everything, I need you to secure me a pressure here not less than, for example, 5 psig. So you want to make sure that your NBSHA is at least equal the NBSHR by the manufacturer. But for process engineering, we don't go with equal, we go with higher. Because we want to make sure that we don't want to go neck to neck with the requirement and end up cavitating the pump, right? So careful attention must be paid to this. So how do I calculate the NVSH? NVSH is calculated based, so whatever available pressure here. So let's say this is your liquid level here. So this is the first point. You can see there. This is the positive head. This is whatever. This is the pressure here. So this is the yes. So what is the summation? This is your pressure. Also, you have what? Static pressure. Static pressure. What do we have also? We have pipe friction, right? Also, the most important parameter that we need to know to come up with the NVSH is the fluid vapor pressure. So eventually, when we sum this pressure plus this static pressure, then we subtract the pipe friction and the vapor pressure. We want to end up with a value here that is the NVSHA, and we want it to be more than the NVSHR. So this is the main thing behind the NVSH. So if the NVSHA, the available net positive suction head at your bomb section, is sufficient and more than the NVSHR, then cavitation will not be there, will not happen. On the other hand, if your summation of pressure, available pressure, and you subtract the frictional losses and the vapor pressure, and you come up with NVSHA that is less than the NVSHR, you will cavitate the bomb. So we have to pay attention to the bomb inlet pipe. So for example, what do we do if we find out that we have this case? We might increase the pipe diameter, right? To go around the frictional losses. So if I increase the pipe diameter, I will have less pressure drop. So maybe I will reduce this value and end up with a value that is more than the NVSHR, right? So sometimes you don't have that. Even if you increase the pipe diameter by any means, you will have to dig in the ground and place your pump down so that you can build the required pressure so that you supply to your pump.
You can make like reduce for the pump.
We can what?
Can reduce the for the pump. So we can increase the pressure for the intersection or not.
You want to have a reducer
At the end of the line for the section of the pump.
Reducer at the end of the line. So what you are saying is, so here, you want to have a reducer. Pipe size will go from, for example, 6 inch to 4 inch. So we will have more pressure, you are saying. Usually it is avoidable. It is not recommended to have such a schematic at the pump section. And how much pressure gain you will get? Negligible. Negligible in that case.
Maybe we play with the temperature to reduce the vapor pressure, so we decrease the temperature.
It is usually out of your control. If it's coming with this temperature, what will you do? For example, you have this crude oil, Arab heavy crude oil tank in Ju'ayna. So what will you do to change it from 140 degrees C or something degrees F? You want to drop it by how much so that you can have more vapor pressure?
Can we integrate refrigeration cycle for the pump?
This would be costly. As an engineer, you will always have to compromise between operating heat. It's better for you to dig a hole and install a special kind of pumps called can type of pump, and it is installed below grade, below ground, so that you can build the required static pressure without changing the process operating conditions. Yeah, you change the elevation of the pump so that instead of installing it here, you will dig below grade. That's considered, this is ground level. This is ground level. So you will dig down and install it here, for example. So by then, by the elevation change, you will gain pressure. So it is more preferable to have this rather than touching or playing with the process parameters, which are usually not feasible. The last thing about line sizing is there are some lines, special lines, that are not steady state conditions. So in these lines, like depressurizing line, so for example, let's say we have sales gas or gas that is distributed among the kingdom. We currently have what's called sales gas network, managed and operated by Saudi Aramco, and it is distributing sales gas or gas to all various users, and they use it as a fuel. So for that network, they have some portions that they want to take for maintenance. So they isolate 3 kilometers of that pipe and they want to depressurize it because it's pressurized, right? And it is serving users. So they want to maintain that portion. So how do they maintain it? First, by depressurizing it. During that event, during that depressurization, reducing that very high pressure to low pressure, you have piping system going to flares or going to burn beds or to be burned, and these can have very high velocities. So you can size that pipe going for the depressurization to have very high velocities, and the reason why, because it is intermittent. It is not a continuous process. If it was continuous, you will not size it with very high velocities. For these specific cases, there is a concept what is called Mach number. Mach number is the ratio between the fluid velocity and the sound velocity. So if your Mach number is international standard and local standards as well, they say if you are within 0.5 to 0.8 Mach, which is approximately 270 meters per second, 270 meters, like a bullet. You can have that for that piping system. It's okay to have very high velocities for that specific service because this is only intermittent and will happen for a few hours only within the maybe the lifespan of the network. So this is another thing I want you to keep in mind when you do line sizing or pipe line sizing, so that you know that some special piping systems can endure high velocities. And the reason behind that, the reason we allow that is because these are only for a specific period of time, not all the time.
شباب الميكانيكال مادة E 425 مناسبة فلو دي فلو أنا فوكس على هذا الكونسبت ما أدري إذا أحد أخذها ولا لا E 425 يتكلم يعني حتى عن الإفكت مو بس السايزنج حتى اللينث لأنه يتغير مع الفيلوسيتي ويصير في شوك في النص وما أدري إيش.
These are just very general process engineering software. So these hydraulic or line sizing, they are not done by hand calculations. There are software used to build your system from A to Z, and you can size your piping system accordingly. Some of these software are listed here, like Aspen ISIS, Atom, Pipe Phase, PipeNets, SPS, Synergy Pipeline Simulator, Olga. So, depending on the phase, some of them are compatible for single phase gas, some of them are compatible with single phase liquid, some are for both, like Olga here. Olga is mainly used for 2-phase. So, you have to select accordingly in case you want to size your pipe, depending on the service of the piping. If you go to companies, some companies they have in-house Excel tablets based on the normal equation, continuity, Bernoulli, done as an Excel, and you can use them all. So, just I want to go through.
بالنسبة للأكوستكس سوي أحد هذه السوفت وير تحديد أكوستكس اندوسمنت لما يكون الفلور
Noise.
إيه سوي الأناليسيس هذه ما تسوي
ISIS, in ISIS, what Muhammad is talking about, sometimes due to depressurizing a segment of a piping with high velocities, you might endure high noises inside the piping system. And this software, except for HISIS, HISIS is capable. HISIS is capable of determining the CV value of that valve that is throttling or depressurizing the system. And there is an equation in international standards to substitute that value and you come with the decibel difference.
طبعا حسب معلوماتي انا لحد الان ما اعرف ولا شركه في السعوديه موجوده انها تسوي اكوستكس اناليسيس، ما اعرف لعل في. طبعا احنا بناخذ الانبوت من البروسيس كباينري، يقولوا لنا ان هذه اللاينات ان هذه اندر اكوستكس اندوسمنت فايبريشن، يعني اكوستكس عشان الماخ نمبر اللي اليها عالي واجد. فاحنا نسوي لها هايلايت ونحدد الليمت اليها from where from up to يعني، وبالتالي نسوي لها رز الى عاد وين تروح هيوستن، تروح البهاما، تروح شناي، نسوي الاناليسيس هناك، بالتالي يجيبوا الانبوت مره ثانيه تروح للبروسيس وهكذا وتستلم ثاني للكلاينت. فانا كانت نقطه رفعت الى واحد من الدكاتره، هل ممكن ان تصير ماتيريال او تعليم او تيتشنج الى هذه الاناليسيس هنا او لا؟ ما ادري، هذه عليكم رفعوها للدكاتره. طبعا كان يلبس متخصص يلبس نشر، وحين ما ادري من الخلف حقه، اسالوا الدكاتره. بس احنا مهتمين يعني انه لو هذا لو يصير خبني نسوي مان باور.
So I'll just do an example of a line size. I brought one Excel template. Suppose that heat material balance is complete, as Yusuf explained. We have a pipe with these conditions. We have, for example, Arab heavy crude oil, and it is at the discharge of a pump, and we want to size that pipe. It is having an operating temperature of 120 degrees Fahrenheit, 150 psig. The mass flow rate is 1,200,000 pounds per hour, and with the following density and viscosity. So just to show you feeling, it's not going to take so long. I know we are about to conclude. So, for example, the operating pressure is 150 degrees. The temperature is 120 degrees Fahrenheit. The flow rate is 1,200,000. And let's say 55 for the density. And this is taken from marine heavy crude coming from Manifa. Manifa producing, they are having the following crude analysis with 55 feet per pound cube and 8 centifoils as a resource. So in this sheet, with these following flow conditions, you have here pipe diameter and the schedule. I will not speak much about schedule. I'm sure the piping will speak about schedules and everything. Let's consider that the schedule for the piping is standard. Okay. Now, let's say that I decided randomly. I don't know what is the best line size to accommodate such mass flow rate or 2,722 gallon per minute. Let's say I want to have it as 8-inch. So this flow sheet will calculate to me now what is the velocity and what is the pressure drop. So if you can look at this here, the pressure drop per 100 feet is 6.06 psi per 100, and average velocity is 70.45, and this is liquid. So from the general velocities and pressure drop guidelines, do you think that 8 inches is a suitable valve size? No, because very high pressure drop and very high velocity at the same time. So if I manipulate, for example, to have it 10 inch. So 10 inch, okay. Now I go to settings. I go back to the presentation and go to. So as an engineer, you don't always have to remember the values. You always go back to guidelines. You are not required to remember. So this is pump discharge, general service. I am okay to have pressure drop of 4 psi and maximum velocity 15. So we are okay. We are okay. So this is just a high level demonstration on how to arrive to pipe sizing. Also there are other softwares available to do this. So this is just, and in case you want to have future expansion, you can try, for example, 12 inch. And if your 12 inch is still within the velocity limits, and for example, this is still within the velocity limits, and you want to, you can't afford the increased cost due to the increased piping sizing, you can go ahead with 12 inch. But you have to justify it. They may come back to you and say, why did you go with 12 rather than 10? You can say, okay, to accommodate future expansion.
وانا احيانا في البروجكت يصير يعني يصير في الستيج انه يجي ريكوايرمنت ويتغير السايز من 10 الى 12.
In the following slides, I'll speak quickly because we are running out of time. But part of information we communicate to piping through the piping and instrumentation diagram. Again, whatever calculations we are doing, selecting we are doing, everything at the end is reflected on one piece, one single diagram, explaining everything to the piping so that they can go ahead with their design. These are the common valve types that you can see in the oil and gas and petrochemical. We have gate valve, globe valve, ball valve, plug valve, butterfly, check valve. Depending on what you need these valves for, you select them. For example, if you want a valve that is for flow control, you will not go with gate valve, for example, because gate valves are only for isolation, either on or off. They are not suitable to regulate a flow because of their nature and mechanical properties and mechanical design. If you try to regulate with a gate valve, you might break the valve itself. So it's not suitable to regulate the flow. Globe valve, however, they are used for flow and pressure regulations. Ball valve used for isolation, and plug valve can be used for either. So there are valves that can be used for either isolation and the regulation of flow or pressure. And the check valve is known. This is a valve that you install to prevent backflow. There are essential services that you need to install check valves. These services are, for example, at the discharge of a pump, you don't want backflow to the pump, right? Because you don't want to damage the blades of the pump. That's why you need to install a check valve at the discharge of a pump. Other aspects on how to select a valve. This is more detailed topic, but I will speak about it very generally. Different valves have different flow coefficients. What I mean to say is, you might have take for example an 8-inch valve. But this valve, sometimes it is a globe, sometimes it is a butterfly, sometimes it's ball. You see the flow coefficients they vary. By the way, it has a unit, gallon per minute per square root of PSI. I will show it in the next slide. I hope I put the units. I forgot to put the units. But this CV value is having the units, and it is a measure of how much flow you can pass through a specific valve. So you might end up with a valve that is 8-inch in all cases, but certain valves they pass certain flow rate. So if you can see here, the ball valve will pass more flow than a globe valve. So this is one of the criteria also to select if you want to select a valve.
طبعا هذا الكونسيبت البايبل فايبريشن.
Yes.
عشان اذا كان الفالف في مشكله في السلكشن يسبب لنا فايبريشن.
Sometimes if your flow rate is this much, and your valve does not pass all of that flow rate, so there might be some vibration on that valve. And the piping team, they have to take that into consideration.
Control valve, are they considered to be gate or gloves?
I didn't hear that.
Control valves, pneumatic control valves. We can consider it like gate valve in case, for example, an SSB, or we can consider it as a globe valve like the one in the separators.
Correct. That's right. That's right. If it's there is an actuator and pneumatic actuator on that, but for example, you will not regulate using that. You will give it a certain set point and you will take it. For example, globe valve, however, can be as a regulator. You can take it from 0% to 100% at any time you want. Other aspects process engineer is responsible for in the piping or in the equipment design is to set the design conditions. There are operating conditions and there are design conditions, and the design conditions are the maximum limits that an equipment or a piping can take, and they are decided based on the operating conditions. So let's suppose that we are designing a pipe and the flow is 120 degrees Fahrenheit as the example I showed. So what is the design pressure of that pipe? We add a certain margin only. It is, most of the cases we add 50 degrees Fahrenheit, and we say, for example, the design temperature of that piping is 120 plus 50, which is 170 degrees Fahrenheit. The reason behind that is for safety reasons. I want to have a pipe designed to take more than what I'm going to operate it for, just for safety as a safety margin. Similarly, for the design pressure, it is the operating pressure plus a design margin. However, for the pressure, it is more sensitive depending on your operating conditions. And there are also international guidelines and local standards that give you a hint based on your operating conditions, what margin you should select, percentage or specific value. I will not go into deep into that, but just to understand, design conditions are operating conditions plus a margin.
طبعا بعض الانواع ما تتحمل بعض الاوبريتنج كونديشن العاليه، هاي قصه مثلا البتر فلان صح؟ الى ليميتيشن ما يتحمل مثلا برشر عالي خلاص حتى الى هنا، فاذا تريد عليه لازم تغير نوع الفالف. احيانا يصير ريكوست خلاص الفالف يتغير مثلا من بتر فلان او شيء يصير.
There is also one important aspect a process engineer does, and they transfer it to piping engineering, which is called flange rating selection. And so, for example, I'm designing a pipe that is having a design temperature and design pressure. It is a very easy exercise. You go to ASTP 16.5, and there is a table there. However, for simplicity, we have that tabulated. So I will just give you a very quick example. So let's say you want to choose a flange rating for a pipe, and that pipe is having a design temperature, for example, as I said, 170 degrees Fahrenheit, and and the operating condition of that pipe was 150. So let's say 160 or 170, let's say 180 PSIG are the design pressure for that piping. So what I'm having here in this plot, this is the red circle here, this is the plot. This is the plotted point based on my design pressure and design temperature, and it's coming at this point. So based on this is the red line. So red line, and it is what? It is the diamonds. So this is the diamonds, the red lines here. So it is telling me that you can go for 150 pound flange rating. Muhammad, are you going to speak about the class flange rating and everything? So further details will be done by the piping team in the following days. They will explain exactly in more details the flange rating, the types, how many flange rating we have. I think we have 7. Yes, the common use are 7. depending on your design conditions. You can go with higher flange rating or higher operating pressures and design pressures, or low ratings for low design temperatures and pressures. I'm about to conclude. So another thing that is shown on a vibing and instrumentation diagram, but however our vibing team, they don't really pay attention to, or they don't bother with their details, which is the instrumentation and the process safety. And main things is what we show. For example, if we have this vessel, this is a separation vessel, snapshot of a BNID. So in addition to the vibing system, this and control valves and whatever valves, we have safety aspects. So we are protecting the equipment from overpressure. This is something a process engineer is doing to protect the equipment. Also, we show all of the flow level measurements, process and temperature measurements, control valves, and process safety, and this is reflected on the BNID. So I'll just finish by showing you some examples of the BNIDs. I purposely chose this BNID because it is scary and suggestive. It is having everything. You can think of anything. I'll just give you an example. By the way, I was joking when I said purposely chose this. That's scary. Okay. Take this line or pipe. This is a BNID showing a pipe going from this to this portion. You will see an identification on top of the line. And in this identification, if I zoom in, important information are delivered to the piping engineer. The first portion is the pipe size. This is 4 inch. Another information is the service of what is the fluid inside. So certain shortcuts are used to show the fluid. Here, in this case, this is steam, 60-pound steam, so low pressure steam. This is the line identification number. So I know that when I say go to line 0389, I know I mean this line. And the last thing is the material and the class rating. So the first digit here, the number 1 is corresponding to flange rating. This is CC, this is the material, and this is related to corrosion allowance. So a lot of information are communicated through this single line identification.
طبعا بتكون عندكم ليجند هذه الرموز تختلف من
Yes.
كلاينت الى كلاينت.
Yes. From a plant operator to a plant operator, such legends and information they vary. So, for example, the way we show the material is different in Aramco projects than Sabic projects, than Shell, than any other ones, and they have their own way. And just referring to a legend sheet, you can conclude on what is the type of material used.
This is the piping class, right?
Yeah, the number 1 here.
No, the whole.
It's called pipe identification or pipe number. What is pipe ID? Pipe ID. It is the ID of that pipe that explains or shows all of the required information from pipe size, material, etc.
1cc 1b هذا السبيسيفيكيشن هذا الباي باسكت. فاذا تريد تعرف هذه ترجع الى البايبنج ماتيريال سبيسيفيكيشن يشرحوها هذه الاربعه.
هذه حاجات تشويقيه عشان
يمكن يوم الاربعاء يشرحها بالتفصيل.
So this is the last deliverable that is piping is more concerned about is the line list, or what we call line designation table. In this line designation table, you remember 0389? This is the line number we show here at the beginning. Then we show the line size, this is 4 inch. Then the pipe spec, which is in our case here it was 1cc, 1p, for example. Then we show that if this insulation of or there is a we show the service. This is sales gas, this is gasoline, this is a general hydrocarbon. Also we show where this pipe portion is coming from or where is it ending. We are showing the design pressure and design pressure. the phase, is it gas or liquid, the operating conditions, flow rate, velocities, densities, viscosities, everything about the pipe, the flow inside that segment of a pipe, we show it in that line list. That's why it is a very important deliverable or input from process, and we give it to piping for their work.
طبعا هذه مختصرة يعني بريف. فيها
Yes.
بريفين ما شاء الله، هذه سمبل يعني.
يعني نشوف
وطبعا زي ما قالوا الشباب على الشركات في العاده اللي ما تدخل في الديب انجينير تكون لديها سمبل. لا دخل في الديتيل لا تكون.
The rest is related to things that my colleagues will further explain, because I think the time is up, right? So we will, I think by this we need to conclude. This brings us to the end of the process part, which is only an introduction or what is process is doing as preparation for the piping work. The floor is open for any question if you have. I think it was an interactive session, so questions were asked about the session. But if you have anything,